The objective of our project is to design a wind turbine that aligns with the direction of the wind to maximize energy generation.
First, since we're using a motor controller, we have to establish the pins that are going to communicate to our processor. After that, we have to establish a value, a tolerance within our code. This value for tolerance basically represents the fact that when the sensor gets closer to zero, meaning that it is perpendicular to the wind direction, it will stop. This happens at 0 degrees, but we want to have some tolerance, 10-degree tolerance, either minus or plus, so that the motor does not jitter. After that, we set up the hold wind direction sensor and do call an address from the previously stated library. Our setup is to establish the setup for our motor controller. We establish a baud and establish the initial condition of the motor to be off. Then we can finally start with the loop that's going to be running and creating the whole self-adjusting part of our project. We establish a wind angle, which the sensor is going to be continuously reading and causing the motor to rotate accordingly. Wind direction sensor is continuously reading an angle. We can finally establish a difference. That is basically the angle that it's reading and the 0-degree angle that we're trying to achieve, or within the tolerance as we previously stated. Over here, the tolerance comes back. The motor will rotate according to this difference. First case is that the angle is within difference. If this happens, we stop the motor and no motion has to be done, since the wind turbine is facing the wind head on. If the angle is not between the tolerance, rather from 5 to 180 degrees, this difference will be positive and the motor will rotate clockwise. We establish this by changing this to high and this to low. We establish the speed of the motor and print the direction in which it is rotating. If the angle is between 5 and 180, this means that the difference is negative. We change the inputs over here to low, high, meaning that it rotates counterclockwise. We establish the PWM, which gives the speed to our motor, and signal that it is rotating counterclockwise. That is how our code works.
This was our first test of controlling the motor with the code. We simulated the wind direction sensor, giving the motor an angle, and then our code turned the motor toward that angle. Once we got our code working and assembled the wind turbine, we tested it. As you can see, the wind turbine moves in the same direction that the wind direction sensor is turned toward.
At this stage of the process, we finalized our aesthetic design of the turbine. We painted the base white, and then we also made the electrical more neat, and we used cable ties and mounted the Arduino and some other components we used onto a wood shelf below the